Okay. Well, I was checking Rich Friedrich's website, and my RIC 2 kit looks like they'll start shipping mid-November now, which is good. I think the description was that they're going to be adding more content when they ship. I'm guessing more paperwork and so on, and research papers, which is really cool. So that I guess also gives me some time to see if I can figure out before I receive my kit. So here's my setup as is right now, and I figure I'd just take some time to show off a few things. I definitely can say do not have everything working, but we'll take a look at that. But let's just walk through and everybody can kind of see where my circuit is right now, and we'll talk about some plans for moving forward. So, function generator, as usual. Right now I just have it set on 25% duty cycle, so I'm hitting it about, half harmonic. Gate driver still there, and L1 series resonant with the variable capacitor to help tune it in. I have been kind of going back and forth between my 25 footer and my 12 and a half footer, given that these two L2s are both 50 feet. Just seeing if there's a big difference between the two. I do have a little bit easier time tuning my 12 and a half footer just due to the lower inductance with the variable capacitors that I currently have. L2A and B. I have been playing around with the pure resistive ground shunt. I have tried 100 ohms and 10 ohms. 10 ohms is actually giving me a little more brightness on my light versus the 100 ohm without any additional current draw, so that was cool. I'm still doing the two diodes out. Here I have the collection capacitor, just kind of keeping that at 1 microfarad at this point in time. I did add a timing circuit here from the second channel of my function generator, so I can kind of tune 60 hertz, 400 hertz, and so on and so on. Diode in between, and then here's my output transformer. Right now, I'm keeping it simple. I do have other options I can play around with there. I did add a capacitor across the primary of the transformer, just so if I could find the resonance frequency, I could put it in there. And then output LED. I do have this diode as an output ground shunt at the moment. And I'm probably going to play around with different options there too. So let's just take a look at where things are currently at. I'll run the system. Again, I'm not really seeing huge benefits right now. I think there's a lot of things I got to go after. But then we can talk down where my plan is to modify things and try things moving forward. Okay, so right now I have my second channel of my function generator set to 400 hertz. I can take this up and down. I need to kind of adjust the duty cycle as well. That pulses the collection capacitor through the transformer and also shuts it off to give it time to come back up to a voltage again. Been playing around with the tuning of the L1 and L2. From my VNA, I know I'm in the kind of 2.4 to 2.5 megahertz ranges. Every time I slide it in a little bit, change things a little bit, that is also adjusting that tuning, and just keeping at the 25% duty cycle right now, and running a 20 volt input. So let me start up the L1. I'll talk about the scope channels in just a moment. But we're able to light the light bulb. It's not super bright. I would say, I would need to measure this exactly, but we're probably around somewhere around slightly less than 1 watt. And you can kind of calculate that as 1 watt right there. We're generally in that area just to get a feeling for the brightness. The purple channel, and you can see little changes when my ground shunt becomes disconnected. The purple channel is my collection capacitor, and you can see the pulse. The yellow channel is the output of the secondary of the transformer. And if I modify channel 2, frequency, You can see, obviously, changes the frequency. And there's a lot of transformer line from that transformer that I just kind of wound by myself. It doesn't, the scope is kind of interesting. It doesn't show, because I have that diode on the output. I don't know if it really accurately reflects what's going on the collection capacitor, but I do find it kind of interesting that you know, even though you pulse it out, the voltage seems to stay high. So that's kind of the current circuit running. I will show you also that if I, this connection right here is the ground connection for both the capacitor and the primary on the transformer. If I disconnect it, there is a slight brightness difference. Actually, slightly brighter when it's disconnected. Might be hard to tell on the camera. But then also the output changes quite a bit, and I'm assuming this is just because all the ground references are now different. I have had generally more success here also trying to get it more into resonance, the output transformer, rather than collecting it through to the diode. Still playing around a little bit there. So let me take it back down to 400. And then if I connect directly to ground, boom, shuts off. So it does look like there needs to be some kind of output ground shunt, but that's kind of where I'm at today with this current circuit. So let's talk about different options and I think things we're going to plan moving forward. Okay, so kind of breaking up this whole circuit into the different sections. So obviously L1 here, L2 there, the L2 ground shunt, showing there with the 10 ohm resistor, the collection capacitor here, also the diodes, which are these two diodes here, the output ground shunt right now, which is this diode, and the whole resonant transformer and timing circuit as we have there. So let's kind of walk through what I'll be focusing on, changing and not changing. So I'm going to stick with the series resonance right now. It's just simpler with a gate driver. Makes my life a little bit easier. I can build a small parallel driver circuit, and I might do that later as I have some boost converting power supplies that might give me a little bit more voltage out, even up to like 300 if I do good protection of the MOSFET. I'm still kind of going back and forth between the 12.5 foot and the 25 foot L1. Like I said, the 12.5 foot has been easier to tune just because up in this 2.4, 2.5 megahertz range, the variable capacitors I have on hand make my life a little bit easier there. L2 I'm pretty much going to leave alone, other than on both of these guys we'll focus a lot on, I think, tuning, general placement of the L1 against the L2. You can see my L1, and I'll have to estimate if I need to spend some more time on just general construction, making sure things are more matched better, making things more tightly coupled, and so on. I'll have to get a feel for that. The ground shunt. So like I said, I've already started to play around. I've got non-inductive resistors. They actually have some more coming. I've tried the 100 ohm. I've tried the 10 ohm. We've definitely seen better output with the 10 ohm. So I might also try to go less than 10 ohm. But I also want to try some different combinations there again. A very low value cap, or maybe a cap resistor combo. For these two diodes, I'm definitely going to spend some time on doing this simple diode bridge versus maybe a full bridge, and then spend some additional time on the full bridge. You know, how would we connect the negative connection and the ground connections for the full bridge and the capacitor? Should they be connected together? Should they be separated? Should there be a ground shunt? on the negative side here. I've seen a lot of different options in Rich's book, and I'll probably end up playing around with those quite a bit. Collection capacitor, I think I'll just keep it 1 microfarad for this point in time. I do have other options. I got 10, 5, and I can combine them in many other ways. But 1 microfarad I think makes life easy. Also, if you look at what they proposed in the RIC 2 kit, it looks like it's going to be a 1 or a 2 microfarad capacitor. Output ground shunt. You see very interesting things with the diode. But again, if you look at the symbols of the circuits that are from Don and Rich's book, you see a lot of different symbols there. And I'm guessing these combinations of, L2 ground shunt and output ground shunt are going to be very important. Also, their placement is probably going to be important as well. So we'll play around a little bit with that. The transformer, I probably have to do some calculations here. I have a lot of different transformer options, some that I'm winding myself. I have some that are commercially bought. These ones can be described as 2-to-1 that I've wound myself. I have some 10-to-1, and they can be configured in 5-to-1 options. Also, should we think about flipping the transformer around and going from a 1-to-2 or a 1-to-10 ratio. From videos and other things, I think in general we want the resistance of the L2, the resistance of the transformer primary to be lower than the L2 ground shunt. So this is where I'll be focusing here in the next few weeks, since I have some time before I get my RIC 2 kit. Love any feedback from the community and viewers. If you can say, hey, focus here, not there, that's stupid, that's wrong, I'll take it all. Trying to see how we can actually get this thing moving. So again, happy to hear feedback from the community. There's the circuit today, and of course I'll be playing around with a lot of different options. But the more and more I read and watch and I guess consume, let's say the simpler I think this process can be. So I'm trying to keep it simple with the components and not really add stuff, or maybe even look to where we can remove or combine. So there you go. That's where I'm at today. Appreciate any feedback, and thanks for your time. We'll talk to you soon.